And now I want to go into one of the more important things that we got to talk about, which is the work energy theorem. So what we want to do here, let's see, I want to make sure I line up things properly. So here I go. So now we get to the work energy theorem. And the types of energy. So what I want to do here is that I want to sort of like give you an overview, because this is where it starts to get somewhat abstract, okay? And even though we use the phrase energy a fair amount, there's a lot of misconceptions about energy. So I want to be careful here to be as clean as possible. So I want to start with an overview of where we're headed, because you got to really see the whole picture of why we're headed this way. So what we find here is that work is your intuition, without any doubt. Energy is not your intuition. So what we need to do here is that we need to talk about work and energy simultaneously, so you could start making the transition to the word energy. So the work energy theorem what it does here is that it literally defines what energy is. So it defines what energy is. You cannot talk about energy without work. So when I say the word work versus energy, here's what we find. Work is, without any doubt, very intuitive. Why? Because you always are working in some shape or form. Now what we want to do is that we want to translate the work language into energy. And I'm saying that energy is an abstract concept. And then what we're going to do here is that now that we have the work energy theorem, we want to define the types of energy. The types of energies. And the way you're going to see that one type of energy is known as potential. The other one is kinetic. And the other one is thermal. And we'll talk about those as the time comes here. So now that we define energy here, then probably, no, not probably, the most central concept in all of science, without any doubt, is conservation of energy. And so now what we're doing here is that we stop talking about work and only focus on energy. And remember what I said, your intuition is in work, not energy. I know you use the word energy probably all the time. Oh my gosh, I'm so low on energy. Oh, that took so much energy. Guess what? You are not saying energy. When you make statements like that, you are talking about work, not energy. That's what I mean about misconceptions. So we start with a very simple question, right? Question is, What is energy? Right? Seems like so simple. And this is a complicated, long question that we have to answer. And what we're going to say here is, what is energy? It's the work energy theorem that tells us about this. Energy is the measure of a system's. So when we talk about energy, we're talking about a system, which is a little bit surprising. You have to talk about a system when you talk about an energy. It's a measure of the system's capacity to do work. And you're going to see that I keep coming back to that. Okay? I'm going to keep coming back to this in one shape or another. And I will say, multiple times what energy is, because like I said, it's a very abstract concept. So what do I want to do? What I just said here is that the energy idea is about how a system changes when work is done. It's about how a system changes. So what I imagine here is that I have some abstract system. Okay, so here's my system. So I look at my system, and that system, when I say system, it typically has a position and it has some velocity to it. And so what happens here is that now I'm going to come on that system and I'm going to do work. So what I'm saying is that now something does work on the system here. So if something does work on the system, then what I'm saying here is this work changes the system. So what do I mean by that? Well, the system is now going to change. And the way I'm going to change it here is that I'm going to come in and I'm going to draw it with a different color. So let's say here that the system now is this baby blue, light blue. All we know is that this system has changed now. It's a new system. This was the old system. This is the new system. So what we say here is that we say this here. So what this tells us here is this, that something about the system, changed. Something about it. And typically when we say this something change, you're going to see that it's either going to be a speed change or a height change. That's that something. And when that happens here, we say that the system has changed its energy state. You can't visualize energy. And as a consequence of this, it makes it abstract. So when you start talking about energy, you are really talking about things in this thing called the energy space, which is different than everyday types of spaces. It's not a physical space. So now, here we go. Now we're ready to define the work energy theorem. Here we go. So the work energy tells us about the work done on the old system and now how it becomes a new system. And it says this. Oops, spelled that wrong. Actually, I don't want to spell the whole word theorem out. I'm going to abbreviate HTM. So here we go. When work is done, work does not disappear, but reappears as energy. So what this tells us here is that energy is stored work. So when we look at energy, it is stored work here, right? We want to highlight that thing. So if I look at this thing mathematically, this is what it says here, that if I do work, what it does here is it changes that there's maybe not say that there's a change in energy of the system. And this change says that it has to be this change in energy. And it turns out that there are three types of changes of energy. There's something called kinetic energy. There's something called a change in potential energy. And then there's something called a change in thermal energy. This is what it means right here. This is the very, very important work energy theorem that we will use for the rest of the semester in some shape or form. Now, I want to go back to this term called energy is stored work. So what I'm saying here is this. When I say energy is stored work, so here's a visual of one way to think about it. And what I imagine here is that I have a coin. Okay? So imagine that this is a coin. So when I look at this coin here, what I'm seeing here, we already know that there's a side that's what they call it the heads. And then this other side, they call it the tail side. Note that you can't separate the heads from the tail. Right? You can't separate them. Of course you can. They're the same coin. Work and energy behave very similar. An energy coin has two sides of the same thing. So when I look at work and energy, I can't separate them. So I have an energy coin. And when I look at this energy coin, right, one side of this coin is going to be energy, and the other side of the coin is going to be work. I can't separate the two. I can never separate the two. I'll have a change in language, but I cannot separate them. That's what I mean by energy is stored work. Where work is done, I change the energy of the system. That work didn't disappear, it went into energy. If I take energy away, work has to take that energy away. It has to reduce it, but it was work that did it.